In this video, we're going to take a look at central angles and arc measures. A central angle is an angle with its vertex at the center of the circle and its two sides are radii. The sum of all central angles in a circle is 360 degrees, and the degree of the arc formed by the endpoints of a central angle is equal to the degree of the central angle. So there's a nice picture over here of what this is talking about. We have our arc. They've kind of shaded in purple right there. And that arc that intercepts those two radii is equal to the central angle right here in the middle. So the central angle equals the arc that it intercepts. So for this example right here, we have the measure of arc BDC, which is pictured in red, is 286. And so the leftover arc, the minor arc BC, would equal the remainder. So it'd be 360 minus 286, which gives us 74. Another example is this picture here, just talking about vocabulary. It's just picturing the blue is the arc of the circle, and then the central angle is right here in the middle. So notice those are equal in that example as well. All right, so let's just talk quickly about a minor arc versus a major arc versus a semicircle. So a minor arc measures less than 180 degrees, so less than half of the circle. It's pictured over here in the picture in blue. So minor arc is like arc BC. A major arc, so that's pictured in red, so I'm going to use red to write this out, is an arc that measures between 180 and 360. So between 180 degrees and 360 degrees is a major arc. And then a semicircle, pictured nicely over there in green, is exactly half of the circle, which is 180 degrees exactly. So half of a circle, which equals 180 degrees. And hopefully you've heard semicircle before, but major arc is just greater than 180, but of course less than 360. And then a minor arc is less than 180, and of course greater than 0. So just a few things to recall. Congruent arcs are not necessarily across from vertical angles. They might be in a picture and just labeled with symbols like you see here. So you have these angles are equal and they're central angles. So you would therefore know that arc AB, let's say, is congruent to arc CD in this picture. And that's just based on the fact that their central angles are equal, therefore the arcs would be equal. And another thing just to always remember is vertical angles are congruent always. So that's when two lines intersect, the angles opposite of each other are congruent. Now let's take a look at some examples. It says find each angle and arc measure. So we're going to use central angles and their arcs to figure out these questions. So the measure of arc JK. Notice this central angle is 21 degrees. So therefore arc JK would also be 21 degrees because the central angle equals the intercepted arc. Angle JNM. So let's see. Angle JNM would form a linear pair with angle JNK in blue right there. And so we could say 180 minus 21 would give us that measure, which would just be 159. Then they said they want the measure of arc KL. So highlighting the arc KL, that is connected to this angle, which is a vertical angle. So angle KNL is vertical to angle JNM. And so therefore, they would be congruent. So it's also 159 degrees. And by the way, you always want to go the shortest distance between the letters. So notice the measure of arc KL. I went in that direction that I drew, as opposed to going the longer way around. So unless they indicate otherwise, go the shortest distance to find the measure of those arcs when they only have 2 letters. The measure of arc JKM, so let's see, JKM. Let me just pick another color. So from J to K to M. So I do need to go in that order around the picture. And that would give me, let's see, so I have 21 degrees. Directly across would also be 21 degrees. And then I know that the angle right here is 159. So you could just add all that together. We could say 21 plus 159 plus another 21 would give us 201 degrees total for arc JKM. Arc MKL. So let's see, arc M to K to L. So I need to go the other way. So MKL is everything in the circle except for 21 degrees. So an easy way to figure that one out is to say 360 minus the 21 degrees that's not included. And you just get 339 degrees for that one. All right, let's look at number 2. Number 2 says find the measure of angle QUR. So let's see, QUR is right there. And it's vertical with this angle that's right across from it, angle TUS. So they're both 19 degrees. Then they said find arc PQ. So arc PQ would equal that central angle, and there's a little 90-degree symbol right there. So if we say 90 minus 19, we get 71 degrees, which would also equal the measure of that arc, because the central angle equals the arc that it intercepts. All right, arc SR. Let's see, SR is over here. And SR looks like it would be 180 degrees if we went straight across, but we just have to subtract the 19. So if we say 180 minus 19, we get 161 degrees for arc SR, because the angle again equals the arc. That's a common theme in our notes right now. All right, measure of arc QRT. Let me try to grab another color. So QRT would be all of those arcs added together. So we have 19, we have 161, and we have another 19 over here. So if we add all that up, 19 plus 161 plus 19, we get 199 degrees for arc QRT. Then they ask for arc PSR. PSR. Whoops. Let me try that again. So from P to S and then stop at angle R. So PSR is everything except for this 90 degrees. So it would be 360 minus 90, which would just be 270 degrees. And the last one is arc PS. So if you go to arc PS right there, you have this 90-degree angle. So you have a 90-degree arc plus the 19 degrees would give you 109 degrees total, because you just have to add those together to get arc PS. All right, so let's take a look at number 3. So in number 3, they want us to find just what X is equal to. So what we can do is we can add up 15. Let me show you real quick. We have vertical angles in a way, because you can put those two together to equal the 103. So I would say 15 plus 18x minus 2 is all equal to 103, because those are vertical from one another once you look at it from that perspective. So then we have 18x plus 13 equals 103. We can subtract 13, so we get 18x equals 90. And then just divide both sides by 18. So we get x is equal to 5. All right, that's it for number 3. Let's take a look at number 4. 4 wants us to find x and then use x to find the measures of these arcs. So first we could say that JNL forms this semicircle over on this half of the circle. So we would know that 5x plus 23 plus 17x minus 41 would all add up to 180 degrees because that's half of our circle. So then if we combine like terms, we could add together 5x and 17x and get 22x, and add 23 minus 41 and get negative 18. We're just solving for x. So let's add 18. So we get 22x equals 198. Divide both sides by 22. And so we get x equals 9. And we just have to fill that back in to figure out the rest. So let's say 5 times 9 plus 23 would be 45 plus 23, which is 68 degrees for arc JK. And then we want arc MJ. So we could say arc MJ is this semicircle right here, or like half of our circle, minus the 68 degrees for JK would leave us with what's left. So 180 minus 68 would just be 112 degrees left for arc MJ. And then we need arc LMK. So let's see, arc L to M all the way around to K would need to include everything except for the arc that's represented by 17x minus 41, arc LK. And now we know x equals 9, so we could plug that in. So 17 times 9, actually that angle, we could save some time, would equal the one we've already found because they're vertical angles. So that should just equal 112, whether you plugged it in or noticed that it's vertical with the one across from it. And then we would be able to say that arc LMK is 360 minus 112, which would be 248. All right. So let's look at one more example, number 5. So number 5, the spaces are over here. We want to find x and then use it to be able to find the measures of those arcs. So first let's work on finding x. So if you notice with this circle, we have a 90-degree angle right here. And then the rest of the circle, we could say all adds up to the rest of that measure for our circle. So 360 minus 90 would leave us with 270 is what's left. So let's add the rest of those up and set it equal to 270. So 8x plus 21x minus 12 plus 10x plus 9 is all equal to 270. If we combine all of our x terms, we get 39x. And if we combine our constants, we get minus 3, because negative 12 plus 9 would be negative 3. So it simplifies pretty quick to be 39x minus 3 equals 270. And then we can just add 3. So we get 39x equals 273. Divide both sides by 39. So you get x equals 7. All right, so that's our first step. X equals 7. And then they ask us to find the measure of arc WX. Okay, so WX, we just need to plug in the value of x and we'll figure out that arc. Because that would be 21 times 7 minus 12. And so that would give us 135 degrees. Let's just write that over here. Now we need to find the measure of arc YW. So YW, the shortest way to get there would be right there in that direction. So YW we could figure out, because it's 90 degrees plus 8 times x, and we figured out x equals 7. So 8 times 7 is 56 degrees, and 56 plus 90 would give us 146 degrees for that arc. All right, and then we need the measure of arc yx. So that's simple enough. We just have to plug in the x, because yx is this little arc right here. So we just got to figure out 10 times 7 plus 9, which would just give us 79 degrees for that arc. And the last one was arc VXW. So let's see, let me grab one more color. So VXW, I need to go in this direction around. So that would be everything included in the circle except for the 56 degrees, which is arc VW. So I just need to say 360 minus 56, which would leave me with 304 for that last answer to this example. All right, so that's it for our examples of central angles and arc measures. Thank you for listening.